if you apply some force on capital M, which is marked as block B, right? As a result, there will be a resulting acceleration, something a meter per second square must be achieved by the mass B, right? Then what will happen? Now, if you consider this is the mass M of particle A, so obviously once the particle A is found itself in a contact with a non-inertial reference frame, so immediately it will get it will receive pseudo force, and this will be the pseudo force, right? So this will be, suppose, small f pseudo force that we can write down M into A. This is the basic idea. As soon as we will apply unbalanced force on B, B will get accelerated, B will be identified as the non-inertial reference frame. The moment it will get accelerated, it will be treated as a non-inertial reference frame. Immediately, small m will experience pseudo force in the backward direction. That is the basic theory. But now, how this pseudo force will be able to stop the sliding motion or sliding possibility of small m? To understand that, if we do the FBD of the mass small m, that is A, quite natural, its weight mg, that will act vertically downward. If I resolve this mg in two components, I will get the components like this. Geometry wise, this is theta, so this will be theta again. So this component will be mg cos theta, that is the weight component perpendicular to the surface of contact will be mg cos theta. So the component of weight down the inclined plane will be mg sin theta. So that means the mass can slide down the inclined plane with the force of mg sin theta. To stop the mass not to move down the inclined plane, you need to exert some balancing force in the direction upward. Then only you can oppose its downward motion, yes or no? So to do so, if you resolve MA into two components, this MA can be resolved, pseudo force can be resolved in two components, and as per geometry, if this is theta, this can also be theta, right? So this component will be MA cos theta, and this side it will be MA sin theta, right? This side it will be MA sin theta, right? Are you understanding it or not? So the moment when the numerical value of this MA cos theta will be equal to mg sin theta, then only the mass small m, that is the block particle A, will be relatively at rest on the surface of capital B, that is capital M, right? So that means MA cos theta, the component of the pseudo force, that should be equal to the actual force due to which sliding can be possible, that is mg sin theta.